We've touched on this in a couple different ways, but taking it back home to this idea of accelerating scientific discovery. I'm curious, how would you summarize how the work that you're doing here on both the hardware end and the software end is really helping us sort of move the needle on that? And especially I think one of the gaps you said is so much of kind of modern R&D is increasingly data-driven, whereas these kinds of animal studies are sort of still kind of left in the analog days. Yeah. So to what extent also can this help us move sort of the needle into these kinds of studies being more, again, data-driven, computational? And again, we've seen an example of that, but curious to hear your own words.
Sure. So I think one of the big things we're trying to accomplish is having an unofficial standard, meaning we want to have data be the norm. We don't want it to be this fun, creative tool that people are using and saying, oh, look at my cool experiment. We want this cool experiment to be the norm, right? We want people to be data-driven, as you said. We want them to care about their animals, follow the 3R principles, which our tool allows you to follow it better. We want you to have reliable and repeatable data, because if it's not repeatable, then we have to do 7 of the same experiment, right? To hopefully find 2 or 3 that are similar enough, right? Like there's a lot of waste, and waste doesn't just translate to, dead mice. It also translates to a waste of time. Mm-hmm. And time is, as you know, one of the things we can't really get back. Mm-hmm. So I want to make sure that all the researchers and scientists are focusing on the research and not on the maintenance, the animal worries, remembering if they have enough food, like checking on them constantly to make sure that they have what they need to run the experiment correctly and with minimal variability, right? We want to create this infrastructure that is, like I said, just universal, right? And the tricky part with doing this is getting it in the hands of enough people such that it becomes universal, that they see the value, that they talk about the value, and that everybody can see that, oh, maybe there was a better way of doing animal research, and here it is.
Interesting. So what I'm hearing is a lot of building a platform and creating standards that then help sort of scientists get out of their own way, where they don't have to be focused on a lot of these kind of tedious type processes, and be able to focus on sort of the most value add type research and maximize their use of time.
Exactly.
Okay. In your mission statement page, there's sort of some what seems like longer term language around, it says, we're dedicated to building the tools and technologies that enable animal testing less invasively with higher quality data with fewer animals, as you said, using robotics, AI, and genetic engineering. Could you share more, especially about that last piece and genetic engineering and how this all ties in?
Yeah, so the smart cages are the first step to creating a complete ecosystem. Robotics come in to actually automate the lab, which is where our cloud lab comes in, right? So imagine you want to run an experiment, and instead of having to set everything up yourself, you just set up the experiment, and then you say, hey, Olden, can you run this for me? We say, sure. We click a button, or maybe they can even click that button, and now the lab does everything automatically. It changes all the cages, it cleans things up, it replaces food, bottle solution, analyzes everything, whatever you need, right? It's all encompassing. It makes it very easy to actually progress things forward. And the scalability of this is pretty much limitless, right? You just open up more facilities that can do more of this in parallel. So that's the cloud lab. Now there's the genetic engineering that you mentioned, which is where Michael's research from his PhD comes in. And it's you got to talk to him about this a little more, but it's a very cool method of essentially targeting organs, right? So it's like a multi-AAV injection technology. You can look it up. It's from Harvard. But yeah, there's basically a lot that can be done once the tools are in place.